All right, hi guys, happy Friday. Today what we're going to be going over is 7.5, which is inverse functions and relations. What you have are these notes, inverse functions and relations. They go along exactly with the PowerPoint I will be looking at, but you can fill them in if you want. If not, I will give you access to this PowerPoint. So inverse functions and relations. An inverse function is the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So two relations are inverse functions if and only if, right? If and only if one relation contains AB, its inverse contains BA. Basically, an inverse function is the exact opposite of the original function. So you can see that here in the example below. If I have a function 1, 2, 3, 4, 5, 6, the inverse function is the exact opposite, 2, 1, 4, 3, 6, 5. Again, an inverse relation is the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So you exchange x and y for both x and y. If you need to, go ahead and pause the video to get down these notes. You can do that throughout this entire presentation. Just click pause, write down what you need to, and then keep going. So here's an example. You're given a triangle and you're told to find the inverse of the triangle, then graph the inverse. Well, the points of your triangle you can see here are 2, 3, 3, 5, and 5, negative 2. So I'll write those here. We have 3, 5. We have 2, 3. And we have 5, negative 2. This is the triangle. The inverse triangle, which I'll write with the inverse symbol, this negative 1 right here, that just means the inverse. Okay, so negative 1 means inverse. It doesn't mean write it as a fraction. Okay, so negative 1 means the inverse. Okay, so the inverse triangle would just be obtained by switching the x and y's. So this would give me 5, 3, 3, 2, and negative 2, 5. So then all I have to do is graph those points. So 5, 3, 3, 2, and negative 2, 5. When you connect them, you can see that that's the inverse triangle. It's the same shape, but it's just being flipped over this y equals x axis. So as a summary, all you had to do was flip the x's and y's. Again, all you had to do was flip the x's and y's and you found the inverse. So go ahead. Okay, if you tried the checkpoint, you should have gotten 4, 2, 1, 3, negative 2, 1 on the graph. It's the same type of thing we just did. It should reflect over that y equals x line. So that's y equals x. Okay, but as long as you flip the coordinates, you're pretty much good to go. All right, so there are a couple properties of inverses. Here's just a mathematical term, if f of x and f negative 1 of x. Again, this f negative 1 of x, that means inverse. Okay, the negative 1 does not mean fraction, it means inverse. Then f of a equals b if and only if the inverse of b equals a. Okay, so what's important to know is that the inverse of a function is not always a function itself. So if you recall from Algebra 1, you learned about this vertical line test, which is very important. The vertical line test says if you draw a straight line through a graph and it crosses more than once, then it's not a function. So this crosses once, so this is a function, good. This crosses twice, so it's not a function. Here it also crosses twice, so it's not a function. We also have a similar test called the horizontal line test, and this can be used to determine if a function's inverse is a function. So vertical line test tells us if a graph is a function. Horizontal line test tells us if the inverse is a function. So it's the same type of thing, you just draw a line that is horizontal instead of vertical. If it crosses more than once, then it's not a function, or the inverse is not a function. So here, only crosses once, so the inverse is a function. Here only crosses twice, so that's bad. So the inverse is not a function, okay? So here are just a couple examples. I'll go through a few for you. So A, straight line only crosses once. So that means that A is a function. However, a horizontal line crosses twice. That means A's inverse is not a function. All right, so horizontal is the inverse, vertical is just the graph itself. Let's look at G. Okay, no matter where I draw a straight line, it only crosses once. So G is a function. However, if I draw a horizontal line, it does cross twice. So G's inverse is not a function. Okay, so that's all the horizontal and vertical line test says. Moving on, we will be asked to find the graph of an inverse or to find the equation of an inverse. This could also be equation. Okay, there are a couple steps we're going to go through. We're going to first rewrite the function as an equation relating x and y. So let's see that with this example. Number 1, just replace f of x with y equals 2x minus 5. Okay, we just don't want any f of x there. Okay, next we are going to exchange x and y. So exchange just means flip. So I'm going to replace x and y. So x will equal 2y minus 5. That's step 2. Okay, all we're doing is switching x and y. Step 3 says to solve the equation for y. So step 3, what I'm going to do is I'm going to add 5. So x plus 5 equals 2y. And then I'm going to divide by 2. So that gives me x plus 5 over 2 equals y. And that's it. The last step there is just to replace y with the inverse symbol. So x plus 5 over 2 equals the inverse of f of x. And that's our final answer. Okay, so again, we rewrite the function relating x and y. We switch x and y because that's the definition of an inverse. Then we solve the equation for y and replace y with f of negative 1x. And here's our answer. Okay, let me show you one more of these. If we have f of x equals 3x squared, first we write it as y equals 3x squared. Then we switch x and y. So x equals 3y squared. Then we divide by 3, so x over 3 equals y squared. Then we have to take the square root of both sides to get rid of that y squared. Now pay close attention, this is where students mess up. I need a plus or minus x over 3 equals y because I took the square root here. Okay, and then my last step is to replace y with f of negative 1 of x. And that is my final answer. Okay, so switch x and y. Well, I guess first replace f of x with y, then switch x and y, then solve for y and replace y with f negative. Okay, the very last thing we have to learn today is how to verify inverses. All right, so to verify an inverse, it's just using a skill you guys did yesterday. So if you're given two functions, you can determine if they're inverses by finding both of their compositions. All right, so that means both of their compositions means you need to find f of g of x and g of f of x, okay? If both compositions equal x, so once you solve them all down and they equal x, then the functions are inverse functions. Okay, so let's look at this example. I first need to find f of g of x. Okay, so that f of x equals 3x plus 9. So f of g of x equals 3 times g of x plus 9, which equals 3 times 1/3 x minus 3 plus 9, because g of x is 1/3 x minus 3. That's going to give me x minus 9 plus 9, which equals x. Well, like my little definition up here said, it has to equal x. It does. Okay, but now we need to check the other one. So we'll find g of f of x. That equals 1/3 x minus 3. Then g of f of x equals 1/3 times 3x plus 9 minus 3. Because I subbed f of x in, f of x was 3x plus 9. That gave me x plus 3 minus 3, which equaled x. So, because they both equal x, that means, yes, they are inverses. And it's as simple as that. Okay, go ahead and try this checkpoint. All right, I'll sketch it out real quick here for you so you can see if you're right. F of g of x is going to equal 4 times 2 square root of x squared, which equals 4 times 4 times x, which is 16x. Does 16x equal x? No, it doesn't. So they are not inverses. All right. That's the